All right, so 5.5 really is honestly nothing new. It's more of, do you know how like in English class you have to write a paper, and when you write a certain type of paper, it has to be like an MLA format. Do you guys know what I'm talking about?
Yeah. Yeah.
So like today's is more of a format. The process of all the math that you're going to do in today, we've already discussed. You should know all the different things. We're going to factor, we're going to cancel things out, we're going to add common, we're going to add like terms, subtract them, combine them, all that kind of stuff, multiply them, distribute, all the stuff that you've done in the past. It's just going to be a different format. So here's what I mean. In the past, I might have given you 3x. Come on. You don't have to write this yet. Plus 4 plus x squared minus 5x plus 2. And I might just have given you that straight up. But today, I'm going to write it in a different format telling you that I want you to add those two things together. So here's what it's going to look like today. Noah, do you need to take the test from yesterday?
No, I was here yesterday.
Okay. So here's what it's going to look like. We're going to do f plus g at x. That's going to be the format that you're going to see it in, and what that should tell you is that you're really taking the f of g or f of x formula, and you're going to add it to the g of x. And so what they will have done at the beginning of the problem is you will see that they have defined already f of x. It'll say something like f of x equals 3x plus 4, and g of x equals x squared minus 5x plus 2. So what you'll do is, instead of f of x here, you're going to put that in its place. So whenever we replace, you're going to put in with parentheses. That is very important. Not so much for this problem, but for later on. So we just practice using, whenever we plug in, put in parentheses, just because sometimes they don't matter, but sometimes they do. And if you don't put them in when they matter, then you're going to be in trouble. So because this is a plus sign, because there's nothing in front here, I can actually go ahead and drop those parentheses that we were talking about. And what I can do is go, hey, I have like terms up here, and I can start to add them together. I want to put the highest power first, so I'm going to go x squared first. That cancels, or not cancel, I've used it. A positive 3x, a negative 5x gets me a negative 2x. And then a plus 4 and a plus 2 turns into a plus 6, and that would be my final answer for this problem.
We wouldn't have to
Say that again.
We wouldn't have to like factor it at all, or
no,
anything.
No. Only we need to factor is if we have it set equal to 0 or we're trying to solve it. This is standard form. It's fine for us to leave it in. Factored form is something we use when we need to like cancel something out, or if we're trying to see when it equals 0, or it's something we use. But this is fine as an answer to leave it in. Does that make sense?
Mm-hmm.
Teachers, faculty, staff, and students, this concludes our active assailant drill for the month of March. You may now return to safe and normal operation. Once again, faculty, staff, and students, this concludes our drill. You may now return to safe and normal operations in your classrooms and on campus. Thank you, and go Warhawks.
Now, the next thing they could have done is they could basically say the same thing, and f and g can switch around. But they could have said f minus g of x. And what that really means is you're going to take the f function and you're going to minus the g function from that. And in this case, can someone tell me what is going to be very important for us?
The parentheses.
Why would the parentheses be very important for me to make sure I put in this one?
Because you have to distribute the minus some.
This negative has to be distributed. And if I don't have those parentheses there, I'm not going to do that. So this actually turns into 3x plus 4 minus x squared plus 5x and minus 2. And now I'm going to combine like terms. And remember, we can do this in any order as long as we keep the sign. So like when I pull this forward, it's just a negative x squared. And then a plus 3x and a plus 5x turns into 8x. And then this and this turns into a plus 2. And that would be my final answer. I want you to go ahead and do that same problem, except we are going to think of this as g minus f of x. So for the next 2 minutes, go ahead and do that one on your own. All right, what you should have done is now this is going to turn into g of x minus f of x, which actually does change some things because now the x squared minus 5x plus 2 is in front of the subtraction sign. And then minus 3x plus 4. And then that distributes and it becomes x squared minus 5x plus 2 minus 3x minus 4. And then we have x squared minus 8x minus 2, which is a totally different answer. Did anyone get that answer? Raise your hand if you got that. Only 3 people got that answer? Destiny, did you see where you went wrong? Savannah? Can you guys hear me? Orist? Hello?
Yes, I hear you.
Orist, did you get this right or no?
I didn't.
Where'd you go wrong?
I just don't understand it still.
Okay, so ask me a question.
How do you get -4 and -3?
Do you see the negative sign right here?
Oh, so you just put that in front?
Well, right here, do you see how this says f minus, or g minus f of x? This notation signals to me that I'm supposed to take the g function, which is notated right here, and I'm supposed to subtract the f function, which is right here. And then I took the g of x. What is g of x equal to? Well, it's equal to x squared minus 5x plus 2. So instead of writing this, I wrote that in its place. And then the subtraction sign is right here. That's still there. And then instead of writing the f, I wrote the 3x plus 4, which is right there. And then I did math. Then I said, okay, combine like terms. We'll have to distribute the negative sign first. And then the x squared was first. I want to combine the x's, so these two combined and then these two combined. Does that make more sense or no?
Yes.
So you're just replacing, right? Like if I said x equals 3, and then over here I have x squared minus 5x plus 4. Well, you're saying, hey, instead of the x, you can take the x's out and put 3 in its place, right? You understand how to do that, Orist, yes?
Yes.
Well, what I'm telling you is when I say f minus g of x, what this tells you is you're supposed to take the f function and minus the g function. And when I tell you that the f function equals 3x plus 4, instead of writing the f here, you can write what it equals in its place. So you can take this out and put 3x plus 4 in its place. But whenever we do that, we use parentheses, especially when we have a subtraction, because when I put my subtraction here and I put another set of parentheses, you have to distribute that negative.
If you did g minus f, you would get a different answer, right?
Yes. Why?
Okay. No, because like...
Because it's the commutative property. 5 minus 3 is not the same thing as 3 minus 5, right?
Yeah, I was just making sure it's the same.
No, so you're no. I was actually I'm so excited that because I was going to talk about this. So f minus g is not the same as g minus f, right? Those are not going to be equal to each other. But if I did f plus g of x, it should be the same as g plus f of x. Why? Because addition is commutative. That's why 2 plus 3 is the same thing as 3 plus 2. Does that make sense, Orest?
Yes. So how will this get more complicated?
It's not really, I mean, well, we're going to divide them and that kind of stuff, but really, I told you today is not much. Today is more about format. Today is not really new. It's combining like terms. That's what we did here. It's distributing a negative sign. That's what we did there. You know, it's not going to get. It's just a new way of like, so if I write this for you, what do you think that means?
F function times the g function.
So f of x times g of x. And so what is the f of x function for this one? It's x, right? And you're going to times it by 5,000 minus 10x, right? And what happens when I multiply? What does this really look like? Well, since it's multiplication, you could really get like that. And what does that tell you have to do with this x?
Distribute.
And so it would turn into 5,000x minus 10x squared. And there would be my final answer. And what do we know if we did g of x? Or g of f of x? Sorry, g times f of x. Would it get me the same answer, yes or no?
Yes.
Because multiplication is what?
Commutative.
2 times 3 is what?
6.
And 3 times 2 is?
6.
So f of x times g of x is the same thing as g of x times f of x. Does that make sense to everyone?
Yeah. Yeah.
Today is formatting, not a lot of math. What does that mean to you?
That will divide f by g.
Say that again. You're really quiet today.
Sorry.
It's okay.
We'll divide f of x by g of x.
Yep. So f of x divided by g of x. And what is the f of x really? So instead of writing f of x, what am I going to write in its place?
X minus 7.
And instead of g of x, what am I writing in its place?
2x squared minus 13x minus 7.
And what do you think we're going to have to do here now? Now the new formatting is done, now old math kicks in.
You do x minus 7 over 1 divided by 1 over 2x squared minus 13x minus 7.
No. What can we do with this denominator?
We can factor it.
We can try to factor it, and then what could possibly happen when we factor it?
Canceling out.
Yeah, we can we cancel this -7 with this -7 right now?
No.
No, what's the only way we can cancel them is if they're multiplication, correct? So if we have bubbles. So let's work on factoring this. So go ahead, take the next 2 minutes and try to factor that.
Is it 2x minus 7 and x plus 1?
Nope. Mm-mm.
I got
What'd you get, Kelly?
2x plus 1 and x minus 7.
Yes.
Oh, okay. So when I divide by the 14 by 2, I put a 2 in front of the x, but I forgot that.
So here's what we do, Horace, right? We multiply this times this, which tells us that it's 14. That's my target number. This right here says it's different signs. This one tells me the bigger one's negative. So I'm going to go ahead and already kind of think through this and go, okay. And I underline and put this. So then I write x, and I write x, and I go, okay. I need two numbers that multiply to 14, but
14
subtract.
and 1.
Right, and the bigger one was 14, so I put the 14 up here, the 1 up here, and then you divide by 2 here, divide by 2 here. And since this simplifies, that turns into just a x minus 7. And since this doesn't simplify, we pull the 2 in front, and so this becomes 2x plus 1. So then this turns into x minus 7 over x minus 7, 2x plus 1, and then ding, 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 this stuff did cancel out. And what's left up top?
A 1.
Over.
And then over 2.
And then what else do I need to think? What do I need to tell them since I cancel that out? What do I have to tell them over here?
X isn't equal to 7.
And what would happen at this if I graph this? What would this be considered since it canceled out?
I gotta look back for that one.
I'll give you, yeah, there's two of them. There's something that looks like this on a graph, and there's something that looks like this on a graph.
What?
All right.
What?
Janina, you are rocking out. Janina, you had a question. Go ahead. You can just pause your music or turn down, or I don't even care if you have the music in the background.
I was gonna say either vertical or horizontal domain.
This is called a vertical. We chase them. Yeah, this is an asymptote. What is this called?
A point.
No. Something digs.
I do not know.
In the ground. What would you dig in the ground?
Was it just a hole?
Yeah, that's a hole. How do I know the difference between a hole and an asymptote? An asymptote, both of them make the denominator 0. So both of these are going to be either an asymptote or a hole. How do I know the difference? This one right here, because it's still there, it did not cancel out, is considered an asymptote. So if when x equals -1/2, because that would make the denominator 0, which is a no-no, if I put in a -1/2, that would make this 0. So this would be an asymptote. So that would look like this. At x equaling 1/2, we would have this vertical asymptote that we would draw in. At x equaling 7, there would be a hole in the graph. So the graph would maybe look like this, and then all of a sudden when it got to 7, there would be a hole, a physical hole, and then it would continue on. Just reviewing, that's from like chapter 3. So holes cancel out, asymptotes stay. So you have an example of one of each of those. Does that make sense?
Mm-hmm.
All right, last type of one. This is a new one. This is not something that you've probably seen before, but it's really not that, it's not difficult. It's just a new, once you see it, it's pretty, hopefully simple for you. So this is called f of g of 3. And what this means is you always start on the innermost one. And so what you're going to do is right here, you're going to focus on this. So if I told you f of x equaled x squared, and I told you g of x equals x plus 1, whatever is in this bubble right here just replaces the x's for whatever this function is. So right here, I'm going to write this as g. Instead of x, I'm going to put a 3 equals. So instead of this x, what am I going to put in its place?
A 3.
Yeah, plus 1. And then what's 3 plus 1?
4.
So now what this says is g at 3. Anytime you see that, it's equal to a 4. So wherever you see g plus or g at 3, you can take it out. And instead of writing g at 3, I can just write a 4, because this 4 is replacing the g at 3 because it's equal to it. And anytime something is equal, we can take it out and put this in. And what does that tell me to do? That says to take the f function, which normally looks like this. But instead of writing x's, we're going to replace them with 4. So it's going to turn to 4 squared, which equals 16. Did that make sense?
Yeah.
Orest, any questions on that?
No.
Anyone else questions on that? Janina, do you have a question?
Do we not have to put it back into the original? Like we're not supposed to multiply them at all or anything?
So what this means is you take the 3 and you put it in for the g. You get an answer for that. You put that answer into the f function.
Okay.
So when I say f of g at 2, that means I'm going to take 2 and put it into the g function. That's going to give me an answer. Let's say g at 2 equals 7. I'm then going to take the 7 and plug it into the f function, and when I do that, I will get some answer. So it's like you're plugging this into the g, you're getting an answer. You're taking that answer and plugging it into the f, and then that's your final answer. All right, try this one. Oh, I didn't realize it. F of g at 2. And let f of x equal this. G of x equals 3x. And then try this one. Oops. Try both those real quick. These are the problems, the things I just underlined. All right, so what you should have done is this tells you you're supposed to work on the inner one first. So you're supposed to put G at 2. That means you're going to look focused right here. And you're going to go, okay, G at 2 is instead of 3x, it's going to be 3, call the timeout, pull the x out, and put the 2 in its place. So G at 2 is really equal to 6. So that means anytime that I see a G of 2, I can pull it out. So instead of writing F at G at 2, instead of writing G at 2, I can write, that means F at 6, which means instead of writing this, I can write it as 2 times, call the timeout, put the 6 in its place, minus 1, 12 minus 1, which is 11. Did anyone get the answer of 11 for F at G at 2? Go ahead and raise your hand if you got that. Very nice. If you didn't get it, does anyone have any questions on that? Do you see what I mean about how it's not really any new math? It's just kind of a new format of writing it.
Yeah.
All right, so what does it mean to be, oh, I did it, of x. Sorry, this should have meant it 2. Sorry. We're going to do that one in just a second, but not right now. I didn't mean to give that to you. Sorry. So what you should have done is you should have, if I would have done this correctly, you should have taken f at 2. So this would mean f at 2, which is going to be 2, replace the x. Notice I always use parentheses when I plug it in. So this turns into 4 minus 1, which is 3. And that means that f at 2 is really equal to 3. So instead of writing this as f at 2, I can really write g at 3, because f at 2 is equal to that. So then I'm going to go, okay, g at 3 is really equal to 3 times 3, which is 9. Totally different answer than the one we got last time. Janina, do you have a question?
No, sorry.
You're okay. All right, last one that I have to show you is this thing that's called, it is called f of g of x. And so what happens is, remember, whatever's in the parentheses replaces whatever our x is. So when I say f at x equals x squared, and I say g of x equals x plus 1, since there's nothing for me to plug into, what I can do is I can say, okay, what does g of x equal? Well, g of x equals x plus 1. Sorry, I'll do this real quick. So this turns into f at x plus 1. And then what happens is when I go to write this f function, instead of writing the x, I take it out, and whatever's in the parentheses goes inside there. So all this turns into is just x plus 1. That's replacing the x, and then the squared is still there. That's from right there. And then we can distribute that out, and it would turn into x squared plus 2x plus 1. And that would be my final answer. And that's it. So you'll have practice on that tomorrow when you come in class. Thank you guys. Hope you have a wonderful day.
Do we have any homework on it?
You will not have any homework tonight.
Okay. Have a good day.